Here we're going to look at question 29 from the NSAA 2018 paper. In this question, we're told that we have a transverse wave travelling along a rope. The question tells us that the amplitude of this wave is 4 centimetres and the frequency of the wave is 10 Hz. Finally, it tells us that the wave moves along the rope at a speed of 2.4 metres per second. The question asks, what is the total distance travelled by a particle on the rope? So, to answer this question, let's think about what a transverse wave on a rope would look like. We could consider a particle on our rope, which would move up and down as the waves travel along the rope in the direction perpendicular to their oscillation. If we consider one oscillation of our wave, then our particle shall move 4 centimetres, then a following 4 centimetres, before moving up again 4 centimetres, and then a following 4 centimetres. So, in total, for one oscillation, the particle shall have moved 16 centimetres. Now, we also know that our frequency of 10 Hz means that our wave oscillates at a rate of 10 oscillations per second. Therefore, in our time period of 20 seconds, the wave shall experience 200 oscillations. So to find the total distance travelled by a particle in our rope in 20 seconds, we can multiply the distance per oscillation of 16 centimetres by the number of oscillations, 200. So doing this in metres, we find that we get a final answer of 32 metres, corresponding to answer E. It's worth mentioning at this point that our answer did at no point require the wave speed of 2.4 metres per second. This is because the wave speed is perpendicular to the motion of our particle, so it doesn't affect how far the particle is going to move. We should also mention that since this is a transverse wave and not a standing wave, that we can consider a particle at any point on the wave. This is because all particles on the wave shall oscillate between the maximum and minimum amplitudes, so it doesn't matter which point we shall pick.